Welcome to this special deep dive. Today, we're looking at the world through a specifically theological lens.
That's right.
Our subject is a really profound resonance between the Nobel Prize in Physics, the 2025 prize, and the deep mysteries of quantum mechanics.
It's quite a topic, an extraordinary chance, really, to see where cutting-edge science kind of bumps up against spiritual wonder.
Exactly. And it's an important mission we've set ourselves. We've got a stack of sources here.
We do. We're looking at the official Nobel information, of course, but also digging into some detailed theological commentary.
Yeah, like the piece Quantum Mysteries and the Creator's Revelation, and another essay looking at how the scientific spirit and Christian faith can converge, that reverence for truth idea.
Finding common ground in the search for truth.
Our goal today is really to connect those dots. We want to unpack how these latest scientific breakthroughs, specifically the one recognized by the 2025 Nobel Prize, might actually confirm or maybe deepen our understanding of faith, of cosmic order, divine sovereignty.
And maybe even the idea of wisdom sort of woven into the fabric of creation itself.
Right, and this isn't about setting science against faith. Not at all.
No, it's more about seeing how the rigorous search for scientific truth can maybe inform and even expand our spiritual grasp of the universe.
So to do that properly, I think we need to start with the science itself.
Absolutely. We have to get our heads around the physics first, because the specifics there are really the key that unlocks the theological thinking later on.
Okay, so the 2025 Nobel Prize in Physics, it went to John Clarke, Michel Devoret, and John Martinis. And it was for something pretty profound.
It really was.
They essentially took let's call them the bizarre rules of the quantum world.
Yeah.
The stuff we usually think only applies to tiny subatomic particles.
The microscopic realm.
And they showed that these rules are actually concrete, controllable, in systems big enough to see, big enough to hold in your hand, almost.
Yeah, centimeter-sized circuits, that's the mind-bending part. For decades, quantum mechanics described behavior that just defied common sense things like superposition, uncertainty, energy coming in packets.
Leaps, yeah.
Exactly. But the thinking was always that as soon as you scale that up, as soon as it interacts with the bigger world, all that weirdness just vanishes. It should just average out and behave classically.
Like everyday physics.
Like everyday physics. But Clarke, Devoret, and Martinis, they prove that's not always true. They created conditions where two really core quantum phenomena showed up clearly on this macroscopic scale.
And those were?
Macroscopic quantum tunneling, we'll get into that, and energy quantization. Basically quantum weirdness, but writ large, on a scale that actually matters for engineering, for technology.
Okay, so how do they do it? What's the mechanism?
The core tool, the foundation for their experiments, is something called a Josephson junction. So imagine you have an electrical circuit, but it's made of superconducting material. And in that circuit, you have two pieces of this superconductor separated by a really, really thin sliver of insulating material, just a tiny gap.
Okay.
That whole assembly superconductor, insulator, superconductor, that's the Josephson junction. And it's the superconductivity itself that makes the macroscopic quantum state possible.
Superconductivity. That's when materials lose all electrical resistance at very low temperatures, right?
Exactly, near absolute zero. And something really crucial happens to the electrons in that state. They don't act like normal electrons anymore. They form pairs. Cooper pairs.
Cooper pairs.
Yeah.
Okay, let's unpack that because the sources really emphasize this distinction. How are Cooper pairs different from just, regular electrons buzzing around?
It's fundamental. Ordinary electrons, physicists call them fermions. They have this inherent individuality. They obey something called the Pauli exclusion principle. Which basically means no two identical electrons can be in the exact same place doing the exact same thing at the same time. Think of them like, very antisocial particles. They need their space. They jostle, they push, they stay distinct.
Okay, like electrons in atomic shells. They have their own unique slots.
Precisely. But Cooper pairs, which are formed by two electrons pairing up through a sort of interaction with the metal's structure, they behave completely differently. They effectively become what physicists call bosons.
Bosons. Okay, different category. What's the key difference there?
The crucial thing about bosons is they don't have that strong individuality. They're more social.
Right.
And this is the absolute key. Unlike fermions, multiple bosons can occupy the exact same quantum state simultaneously.
So they can all pile into the same spot doing the same thing?
They can all be in the same state. And this is revolutionary for the circuit because you have billions upon billions of these Cooper pairs in the superconductor. And because they can all exist in the same quantum state, they stop acting like billions of separate little things pushing through the wire.
They act together.
They act totally together, as one. The sources describe it beautifully as a synchronized dance. This huge collection of Cooper pairs flows in perfect unison.
Like a single entity.
Exactly. The entire macroscopic system, this centimeter-sized circuit, can be described by a single wave function.
Wow. Okay, so instead of needing, like, a bazillion equations for each pair,
Right.
you just need one equation.
Yeah.
One wave function that tells you the probability of finding the entire circuit in a certain state.
That's it. The whole circuit effectively behaves like one giant quantum mechanical particle. The coherence, the synchronization is total across the whole thing.
And the Josephson junction, that weak link you mentioned.
That's critical because it allows them to control and, crucially, to measure the coherence, that coordinated rhythm of this giant quantum entity. Being able to manipulate and measure that shared wave function on this scale, that's the heart of the Nobel breakthrough.
And it takes quantum theory out of the abstract and into
Practical engineering, things like ultrasensitive quantum sensors, and it's a massive step towards building more robust quantum computers.
Okay, that clarifies the technical foundation. The big takeaway seems to be this incredible unity, the whole system acting as one. Now, let's explore what the behavior of that unified system tells us, especially regarding energy. This brings us to the first phenomenon they observed.
Yes, that unified system, that giant quantum particle, immediately shows something profound when you look at how it handles energy. This is the first phenomenon they confirmed. Energy quantization.
Quantization.
Yeah.
Meaning discrete packets,
Yeah.
right? Not smooth.
Exactly. So this macroscopic circuit, you'd classically expect its energy to vary smoothly. Like you add a bit of energy, its energy level goes up a bit, add more, it goes up more, continuously.
Filling a cup with water.
Right. But that's not what happens. This quantum system only absorbs or releases energy in specific fixed amounts, discrete chunks, quanta.
So it jumps between energy levels. It can't just exist between levels.
Precisely. They showed this very clearly by shining microwaves onto the circuit. If the circuit were classical, it would just absorb energy from any microwave frequency warming up smoothly.
Makes sense.
But the quantum circuit was picky. It only absorbed energy from microwaves of very specific, distinct frequencies or wavelengths. If the frequency was just slightly off, nothing happened. It completely ignored the energy.
Wow.
It would only jump to a higher energy level if the incoming energy packet was exactly the right size to match the gap between its allowed levels.
And this confirms a core prediction of quantum mechanics, but seeing it happen in something you can literally hold,
Yeah.
that's the amazing part.
That's what's astonishing, because you might expect classical physics, the physics of big things, to take over. But no, the fundamental quantum rule holds. And the theological sources we looked at find this incredibly significant.
How so? Why is energy coming in discrete chunks theologically interesting?
Well, the interpretation is that this provides powerful physical evidence for an inherent, meticulous order in the universe. Think about it. A universe running on continuous variables might suggest, fluidity, maybe even randomness at its base.
Okay.
But a universe structured around discrete, fixed quantum points towards a foundation built on precise measure, on number, on defined limits. It suggests creation isn't chaos, but a kind of higher-level choreography with its own internal rhythm and rules.
The commentary you mentioned draws a direct line to that apocryphal text, Wisdom 11.20.
That's right. You used measure, mass, and number to arrange all things. The physics here seems to demonstrate that idea quite literally. Energy, the fundamental currency of reality, isn't just a free-flowing river. It's structured by numerical measure. It comes in specific quantities.
So the idea of a quantized design, it argues against sort of ultimate fuzziness.
Exactly. If the creation operates on fixed numbers and specific boundaries, even at the level of energy itself, it really seems to validate this concept of divine measure and deliberate limits. The scientist, by measuring these fixed quanta, is, in a way, reading the designer's blueprint, finding a strict methodology.
And this idea of strict rules then leads to the next point, consistency. The same rules applying everywhere.
Yes, the principle of interconsistency. And this is maybe where the Nobel work is most compelling for the theological reflection in our sources.
Because the quantum rules worked on the big scale too.
Precisely that. The very fact that the rules of quantum mechanics rules figured out by looking at single atoms, tiny particles apply identically and precisely to this system made of billions of particles acting as one. That confirms an amazing uniformity. a consistency in the design principle.
The governing laws don't suddenly change when you go from small to big.
No shift. And that macroscopic quantum state itself, the billions of Cooper pairs unified by that single wave function that resonates powerfully with scriptural ideas of cosmic coherence.
You're thinking of Colossians 1 Son Him.
Exactly. In him, all things hold together. That verse suddenly takes on a more physical dimension, doesn't it?
Yeah, it does.
The holding together isn't just poetic. The science suggests a real unified physical mechanism, that shared wave function that literally binds the system together. It implies the universe is maintained by the same wisdom, the same rules across all scales.
From the atom to the circuit.
And maybe to the cosmos. It echoes Hebrews 1.3 as well, doesn't it? Speaking of the Creator upholding all things by the word of his power, the consistency is key.
So if we were to sum up this part on quantization, the discovery scientifically reinforces the idea that the universe is built on measure and fixed design. It establishes a foundation of order.
An order theologians have long pointed to as evidence of a rational, wise creator. And crucially, that design is unified and consistent across scales.
It suggests that our everyday classical world, where energy seems smooth and continuous,
is really just an approximation. It's what we perceive when we average over the deeper reality, which is fundamentally structured, numeric, and defined by these precise, maybe even divine measures.
Okay, so if quantization speaks to order and measure, the second big discovery, the confirmed macroscopic quantum tunneling, or MQT, this seems to speak more to, well, breaking the rules, or at least our understanding of them.
It definitely challenges our everyday intuition, even more than quantization, perhaps. It touches on divine sovereignty, transcendence of limits.
Because tunneling in classical terms is just flat out impossible.
Completely impossible. Classical physics is very clear. If you have an object, say a ball, and you throw it at a wall, but it doesn't have enough energy to get over the top of the wall,
it bounces back every time.
It bounces back. The probability of it magically appearing on the other side is zero. It needs the energy to overcome the barrier.
But not in the quantum world.
Not in the quantum world.
Yeah.
Because a quantum particle isn't just a little ball. It's described by a probability wave, that wave function we talked about. And that wave function doesn't just stop dead at the barrier. A tiny part of the wave actually leaks through to the other side.
Leaks through the wall.
Mathematically, yes, which means that there's a non-zero calculable probability that the next time you look for the particle, you'll find it on the other side of the barrier. Even though it never had enough energy to classically climb over it, it tunneled through.
That's weird enough for single particles.
Yeah.
But the Nobel Prize was for seeing this happen.
On the macroscopic scale. With their entire superconducting circuit, they essentially set up a situation where the whole circuit was trapped in a state with zero voltage, locked by an energy barrier. It shouldn't have been able to generate a voltage.
But it did.
But it did. Through macroscopic quantum tunneling, the entire system, that giant quantum particle made of billions of Cooper pairs acting in unison, escaped the zero voltage trap. It tunneled through the barrier and produced a measurable electrical voltage.
So the whole circuit effectively passed through a wall it shouldn't have been able to.
That's the essence of it. And seeing billions of synchronized particles pull off this impossible feat together, well, it fundamentally shakes up our intuition about physical limits.
And the theological sources jump on this.
Oh, absolutely. This impossible escape becomes a really powerful metaphor for thinking about God's sovereignty and power.
How so?
It serves as a reminder, grounded in physics, that the boundaries and limits we perceive in the natural world, the rules of classical physics we live by, might not be the absolute final word when viewed from a higher perspective.
It connects directly to Mark 10.27, doesn't it?
It's almost impossible not to think of it. With man, this is impossible, but not with God. All things are possible with God. The sources argue that MQT provides a kind of physical echo of that spiritual reality.
So the argument isn't that God breaks his own laws.
No, the argument is more subtle. It's that just as quantum rules allow for things impossible under classical rules, perhaps biblical miracles aren't arbitrary violations of God's established order either.
Maybe?
Maybe they're manifestations of his higher sovereignty, his ability to operate according to deeper, perhaps quantum-like principles or possibilities that exist outside the limited framework of the classical physics we usually experience. The universe itself, at its quantum foundation, has mechanisms for getting past apparent barriers.
Which really challenges the idea that everything must be predictable, deterministic, based on the equations we normally use.
Exactly. If the very fabric of reality allows for these kinds of impossible breakthroughs from trapped states, it's also a profound statement about the limits of human understanding.
And that limit is underlined by the uncertainty built into quantum mechanics itself, right?
Yes, we touched on this, but it's crucial here. The quantum world isn't deterministic in the classical sense. It's probabilistic. We can calculate the probability of that circuit tunneling out of the trap over a certain time.
But it can predict exactly when it will happen.
No. Before you measure it, the system exists in a superposition of states. It's simultaneously in the trapped state A and D and the escaped state. Only the act of measurement forces it to choose one.
Okay, but wait. If quantizations suggested order and measure, doesn't introducing probability sound like, well, like Einstein famously worried, God playing dice? Doesn't that conflict with the idea of a precise design?
That's a fantastic question, and a tension the sources absolutely address. The argument presented is that this inherent uncertainty isn't necessarily a sign of divine randomness or caprice.
But
Rather, it's a reflection of our cognitive limits. The uncertainty exists from the human perspective. It reinforces that idea from Isaiah 55. My thoughts are not your thoughts, neither are your ways my ways.
our human logic wants things to be perfectly predictable. If A, then always B.
Right. We crave that deterministic certainty. But the quantum world operates differently. You can predict the average outcome over many trials, but not the single event. It suggests God's creative order might incorporate possibilities and potentialities that go beyond our neat, rational frameworks.
And this is tied up with the observer effect, too.
Deeply. The very act of trying to measure or observe the quantum system, like checking if the circuit has tunneled yet inevitably disturbs it, it forces the superposition to collapse into one definite state. You change the reality simply by looking at it.
You can't fully know the quantum state without altering it.
Precisely. And this is where the sources draw another stunning parallel, this time to 1 Corinthians 13.1. Now we see as in a mirror, dimly, or through a glass, darkly.
Our knowledge is incomplete, reflected.
Exactly. This scientific boundary, the unavoidable impact of the observer, resonates perfectly with the scriptural confirmation that our knowledge as created beings is inherently limited. The quantum world doesn't just reveal the limits of certain physical laws, it reveals the limits of our tools, our observation, and ultimately, perhaps, our own minds.
So the creator's design includes aspects, superposition, probability, the observer effect, that are fundamentally beyond our full deterministic grasp.
That seems to be the implication. It points towards a transcendent wisdom that establishes both profound order and inherent possibility simultaneously.
Okay, so we've looked at the science order through quantization, sovereignty, or transcendence, through tunneling. Now let's pivot slightly to how the weirdness itself, the non-deterministic nature of quantum mechanics, might connect to our understanding of faith.
Yes, this brings us back to that idea of the system existing in multiple states at once before we look the superposition.
The O, as the Chinese source material terms it, that state of potential reality.
Right. Before observation, the circuit is potentially trapped and potentially escaped. It exists as a possibility or a set of possibilities waiting to become actual. And the sources draw a really profound philosophical line from this physical reality to the nature of faith.
How so?
Well, think about the classic definition of faith from Hebrews 11.1.
Faith is the substance of things hoped for, the evidence of things not seen.
Exactly. The Greek word often translated as substance, or as the Chinese sources render it, o, which means something like certitude or conviction. Faith is presented as the firm conviction or certainty regarding an unseen reality. Now, compare that to the physicist who accepts the reality of the unobserved quantum superposition based on the consistency and predictive power of the theory.
They have certitude about something they can't directly see until they measure it.
Precisely. So the argument goes, the quantum world itself tells us that unseen realities, uncollapsed potentials, are not just philosophical fluff, they're fundamental to how the cosmos is actually structured.
Which suggests that faith isn't just wishful thinking detached from reality.
But perhaps it's a kind of certainty, a se, aligned with the fact that the full reality, both physical and spiritual, is vastly larger and more possibility-filled than the collapsed classical world we typically observe.
That's a powerful connection. And the sources also bring in another related quantum idea here, right? Entanglement?
Yes. While macroscopic quantum phenomena was the specific Nobel achievement, the related concept of entanglement often comes up in these discussions about unity.
Entanglement being the spooky action at a distance, where two particles remain connected, instantly influencing each other no matter how far apart they are.
That's the one. If you measure the property of one entangled particle, you instantly know the corresponding property of the other, even if it's light years away. There's a non-local connection.
Which implies the universe isn't just a collection of separate bits and pieces.
It implies it might be more like a single interconnected whole, bound by these invisible threads, these correlations that defy classical space and time.
And the theological parallel there is
The idea of cosmic unity, the interconnectedness of all creation. If the physical laws themselves seem to mandate this kind of deep connection, it resonates strongly with the spiritual truth that all things are upheld by Him, or that we share a deep commonality.
like the idea of the spiritual body in 1 Corinthians 12. If one member suffers, all suffer together.
Exactly, that verse. If one member is honored, all rejoice together. Quantum entanglement paints a picture where this kind of mutual connection isn't just a nice metaphor for community, it might reflect a fundamental operating principle of existence itself.
So pulling all these threads together, quantization, tunneling, superposition, entanglement, what's the ultimate synthesis the sources offer?
I think the core conclusion is that these profound scientific discoveries, delving into the deepest layers of reality, they don't shrink our concept of God at all. If anything, they dramatically expand our sense of His mystery and wisdom.
The more we know, the more we realize we don't know.
In a way, yes. Science pushes the boundaries of the knowable, confirming these intricate physical laws even on macroscopic scales. But in doing so, it simultaneously forces us into a deeper reverence for the sheer depth and perhaps the unknowable nature of the divine mind that established those laws in the first place.
We find ourselves, maybe like the scientists themselves, just standing in awe.
Exactly. Awe at the depth of the wisdom that could structure reality this way. It brings to mind that passage from Romans 11:33.
Oh, the depth of the riches of the wisdom and knowledge of God. How unsearchable His judgments and His paths beyond tracing out.
That captures it perfectly. The closer we look at the mechanics, the more complex and counterintuitive and yet perfectly functional it all is. We become more aware of what we can't fully trace or comprehend.
The sources describe the quantum world as a kind of microsculpture.
Yes, where every bit of uncertainty speaks of sovereignty and every quantum of energy declares the Creator's precise measure. It pushes both the scientist and the person of faith towards humility.
A convergence point.
A convergence in reverence, acknowledging that the search for truth, whether through a microscope or through prayer, ultimately leads us to the foot of a profound mystery. #outro.
Wow, that was an incredibly rich and quite dense deep dive today.
It certainly covered a lot of ground.
So just to briefly summarize for everyone listening, the 2025 Nobel Prize work, demonstrating macroscopic quantization and tunneling. It seems to highlight two really fundamental theological principles based on our sources.
That's right. First, the quantization part really underscores the precision, the order, the consistency of the Creator's design. It suggests a universe operating on fixed, maybe even numerical measures, a foundation of intricate order.
And second, the macroscopic quantum tunneling, that impossible escape.
That provides a powerful physical metaphor, or maybe even an echo, of God's transcendence and sovereignty. It demonstrates that the classical limits we usually perceive aren't necessarily the final word on what's possible.
And the overall conclusion seems to be that this quest for truth, whether it's happening in a physics lab or in spiritual reflection, it kind of converges.
It converges in recognizing this profound unified mystery, and maybe the necessity of humility when we stand before the creative wisdom that underlies everything.
Science expands what we know about the universe.
But in doing so, it paradoxically deepens our respect for the perhaps unknowable wisdom that set it all up in the first place.
Which leaves you, our listener, with this final thought question to mull over.
If the fundamental laws of nature themselves, down at the quantum level, seem to contain these echoes of the miraculous things like quantum tunneling that defy classical expectation, how should that influence our understanding of the boundary between what we call natural and supernatural, especially when we encounter unexpected, maybe seemingly impossible events in our own lives?
Something to think about. Thank you so much for joining us for this deep dive. Until next time.